Section 5.6 is where we get to solve equations involving exponential and logarithmic functions. So we are not adding any new techniques to our section, but we do have to remember the previous techniques that we've learned. And a summary of those are as follows: changing from logarithmic form to exponential form, or vice versa. Getting log m equals log n, so that we can get m equals n, or matching the bases a to the m equals a to the n, so that we can equate the exponents, m equals n. Taking a look at the first example, 2 to the x is equal to 5, we might try technique 3 here, except that 5 is not a very convenient power of 2. We could guess that the answer for x should be more than 2 and less than 3, since 2 squared is 4, but 2 cubed is 8. But since we can't guess it exactly, we're going to have to pick a different technique. So how about we try technique number 1, change from exponential form to logarithmic form. So we can use log base 2 of 5 is x. And that's it. We solved for x. This is our solution in exact form. If we want an estimate of what this is using our calculator, we can use the change of base formula and type it into our calculator. But most of the time I want exact form, so I'm not gonna change that. We're done with that one. Our next problem, 8 times 3 to the x is equal to 5. In order for you to use our exponential to logarithmic form, I need 3 to the x isolated by itself. So I'm going to divide both sides by 8 first. And now I'm going to change from exponential to logarithmic form. That is, log base 3 of 5 over 8 is x. And since x is by itself, we are done. We have solved for x. The next example, we notice that there are two log functions, log on each side. So I think the most obvious thing to try would be rule or technique number 2. But in order to use that, it's the log of m is equal to the log of n. I don't want to have this 2 in front of the log. So I'll use the property of logs to bring the 2 and make it the power of x. And now we have log m equals log n. So from here I can say x squared is equal to 9. Solving for x and taking the square root of both sides, I get plus or minus 3. Now we have to be careful when we have log functions at the beginning of the problem, because it's possible that we find an extraneous root, that is a solution that doesn't really work for the original domain of the problem. We know from section whatever it was that the domain of a log function, the stuff you can put inside of a log function, are positives. So if we try to put negative 3 into this problem, it doesn't work. If we try to put positive 3 into the problem, it does work. So our answer is only, or our solution set is only 3 and not negative 3.